Okay, now we're going to go into the application for conduction. So we're going to observe how actually things work. Okay, conduction, how does it help? So most mammals have fur. Okay, most mammals have fur. It helps to keep their body warm. So how come it works? Because the fur traps air, and the air is actually a insulator of heat. So this helps to reduce heat loss from their body. Okay, so actually fur is good, not because the fur is the key thing here. What does the fur do? It traps air, which is an insulator of heat, and it reduces heat loss. That's why furry animals, okay, are the one that need to keep their body warm. Okay, the air trapping is the key there. Next one, penguins have feather, functions the same as fur. What does the feather do? It traps air. So because air is a poor conductor, or we say insulator of heat, so it's helped to prevent heat loss. Next one, okay, feathers. Underneath the feathers, there's also this layer of fats. They are also good insulator of heat. So these two conditions here actually helps to prevent heat loss for animals or birds or creatures that lives in the colder region. Okay, so you can see here for penguins, they have layer of fats. They have feathers that trap air. Okay, now there are also in terms of the materials. So we look at the cooking pan here. Cooking pan is made of metal, which is a good conductor of heat. Okay, because why? It has molecular vibration and free electron diffusion. First one, molecular vibration. Second, free electron diffusion. Okay, to help to conduct heat. Two different methods. So, good conductor heat can be transmitted easily. So when you heat it up, the heat transfers very easily from the flame to the pan, and it will transfer onto the food. Okay, the handle here is generally made out of plastic. Why? Because we want it to be a insulator or poor conductor of heat. Okay, so that means when the pan is heated up, will the handle heat up so easily? No, because it is a poor conductor. It is a insulator. So when the things get hot here, your handle is not so hot at all. So things will get cooked here, and you can still hold on to the pan and you'll feel safe. The other one is icebox. So icebox is made out of plastic and a layer of this thing called the thermocol. Okay, thermocol. Don't need to worry too much what thermocol is. Just take note, it's plastic with this layer called thermocol. These two, the key thing here is that they are poor conductors of heat. So obviously, if they are poor conductor of heat, can heat travel into the icebox easily? No. So it prevents heat from entering the icebox. And so the contents inside here is cooled. Okay, it's kept cool. Keeps cool. You must know the application, okay? So it's about looking at the application and draw some understanding in terms of good conductor, bad conductor. Next one. In winter country, we got this thing called the double glazed window. Okay, they are used to keep houses warm. So you can see here, what do you mean by double glaze? You can see that there are two pieces of mirror, two layers of mirror, okay, two layers of glass. First layer here, second layer here. In between them, there's actually a gap. This gap is either a layer of air or vacuum. Now, why is it going to help in terms of conduction? Because air, we know, is a poor conductor. Air equals poor conductor of heat. So if it's a poor conductor of heat and we put it in between the two glasses, it's going to help prevent heat transfer. So winter, we know outside is cold, inside is hot. So we prevent the heat from within the house to travel out from the house. So that's why double glazed window is good for winter countries. So in terms of the application here, okay, they are actually endless. So you must actually learn how to look at conductors and insulators in terms of conduction and try to so-called try to draw some understanding and application in our daily lives. Okay, so this marks the end of the application for conduction. Next one, we're going to go into convection.